Solids of revolution, the disk method. What is the disk method? Consider the figures below, figures 1 and 2. When the region R in figure 1 is revolved about the x-axis, what happens is that we generate a solid that has circular or disk-shaped cross-sections, as you can see in figure 2. Now recall that the area of a disk, or the area of a circle, is given by pi times its radius squared. Well, in figure 2, our circular cross-section has a radius of f of x. So to compute its area, we're going to multiply pi times its radius squared, in this case, pi times f of x squared. This gives us the following volume formula: V equals the antiderivative from a to b of pi times f of x squared with respect to x. Because the cross-sections are circular, or in the shape of disks, the application of this formula is called the disk method. Now we're going to look at an example of an application of the disk method. The directions are to find the volume of the solid that results when the region enclosed by the given curves is revolved about the x-axis. Here we have the curves y equals 1 plus x to the third, x equals 1, x equals 2, and y equals 0. We're going to write down this information again. Here we have the curve y equals, or f of x equals, 1 plus x to the third power. We have the lines x equals 1, x equals 2, and y equals 0, which is just the equation of the x-axis. And we're rotating about the x-axis. So according to the disk method, the formula for the volume is V equals the antiderivative from x equals 1 to x equals 2 of pi times 1 plus x to the third power squared with respect to x. Since pi is a constant, we can remove it from the integral expression. And so we have pi times the antiderivative from 1 to 2 of 1 plus x to the third power squared with respect to x. At this point, we can go directly to our graphing utility to compute this antiderivative. We'll compute the antiderivative from 1 to 2 of 1 plus x to the third power squared, and then once we get this answer, we'll simply multiply it by pi to get the volume. There's more than one way to compute the antiderivative using our graphing calculators. In particular, I'm going to use a method that doesn't require us to graph. So on the Math menu, we will choose the 9th option, FNINT. Alright, and we're going to integrate the function 1 plus x to the third power, and that entire quantity is squared. Then we're going to put a comma and then x. This lets us know that we are integrating with respect to x. We'll use another comma, and then we'll input the bounds of integration. Our lower bound is x equals 1, and our upper bound is x equals 2. We'll close the parentheses and hit enter. And so we have this result of 26.64285. We're going to convert this to a fraction by going back to the Math menu and choosing option 1. This will convert our decimal into a fraction. And when we're done, we have 373 divided by 14. Now remember, we have to take this answer and multiply it by pi. So from the calculator, we have 373/14, and we're going to multiply that by pi. This gives us a final volume of 373 pi over 14. The disk method has an analog for regions revolved about the y-axis. If you recall from the previous example, the region was revolved about the x-axis. But in this case, if the region in figure 3 is revolved about the y-axis, the solid that is generated will have circular cross-sections that are perpendicular to the y-axis. In this case, our circular cross-section has a radius u of y. Thus, the volume formula becomes the antiderivative from c to d of pi times the radius squared, in this case, pi times u of y squared with respect to y. So in general, when you have a function of x that is being revolved about the y-axis, you have to solve it for x in terms of y. The integration is done with respect to y. Now we're going to look at another application of the disk method, where this time we'll be revolving about the y-axis. Find the volume of the solid that results when the region enclosed by the given curves is revolved about the y-axis. Here we have the curves y equals 2 divided by x, y equals 1, y equals 3, and x equals 0. To label our graph, we'll have f of x, or y, equals 2 divided by x. Here we have the line y equals 3. Here we have the line y equals 1. And here we have the line x equals 0, which is just the equation of the y-axis. To use the disk method to find the volume, we'll integrate from y equals 1 to y equals 3, pi times the function of y squared with respect to y. But as you can see, our function is not a function of y, rather a function of x. So this means we're going to have to solve y equals 2 over x for the variable x. That way we will have x as a function of y. So let's begin. We start with y equals 2 divided by x. To solve for x, we'll begin by multiplying x on both sides of the equation so that the x's on the right-hand side cancel. This gives us xy equals 2. Lastly, we will divide both sides of our equation by y so that the y's on the left will cancel. This gives us x as a function of y, that is, x is equal to 2 divided by y. So, to use the volume formula, we will have volume is equal to the antiderivative from 1 to 3 of pi times the function of y, 2 divided by y, squared with respect to y. Since pi is a constant, we will take it outside of the integral expression, which leaves us with the antiderivative from 1 to 3 of 4 over y squared with respect to y. At this point, we can go directly to the graphing utility to compute the antiderivative of 4 divided by y squared from 1 to 3. Remember, when you get this answer, to multiply it by pi to get the final volume. We'll proceed just as we did with the previous example, but for convenience, we will use the variable x as opposed to the variable y. So we start with clicking the math button, and we will choose the ninth option, which is fnint. We're going to integrate the function 4 divided by x to the second power. Again, on the paper we have 4 divided by y to the second power, but for convenience we're using the variable x. We'll follow that by a comma and then x, which lets the calculator know that we are integrating with respect to the variable x. We will follow it by another comma and then input the bounds of integration. The lower bound is 1 and the upper bound is 3. Close the parentheses and hit enter. And then we will change this decimal to a fraction by going back to the math menu and choosing the first option, which converts this decimal to a fraction. And so we have 8/3. But now remember, we're going to have to take this answer and multiply it by pi. And so the calculator gave us the answer, 8/3, which we are going to multiply by pi to get a final answer of 8/3 pi, or 8 pi over 3.